So again, this is part 3 of our discussion. For most of it, assumption natin is the degree of your numerator f is strictly less than the degree of. So now baligtarin natin yung assumption. What if the degree of your numerator f is greater than or equal to the degree of your denominator? Then hindi tayo pwedeng agad-agad mag-partial fractions dito, no? We will see why in an example later. So instead, ganito yung gagawin natin. Sa lahat, we have to divide f of x by g of x in their expanded forms using long division. And upon doing this process of long division, we will obtain a quotient q of x and a remainder r of x. And take note, yung property nitong remainder na to is that the degree of this remainder r, it's strictly less than the degree of g. We fall back to the first case kapag nasa remainder tayo ngayon. Now, what can we do with this quotient and this remainder? We can write the original function as quotient plus remainder all over the denominator. Remember that, it's quotient plus remainder over denominator. Tapos like what I mentioned, yung degree ng remainder natin dito, it's now less than the degree of the denominator, no? So this one, we can resolve this into partial fraction. Let's now illustrate that with our final example, example number 5. Now take note, ano yung degree ng numerator nyo rito? What's the highest power appearing in your precisely 4. And then for the denominator, the highest power appearing is 2. So yung 4, degree of the numerator, it's larger than the degree of the denominator. We fall back to that case, yung kanina natin. Now, what if we try to decompose this into partial fraction? What happens? As usual, let's factor out the denominator, no? This is not so hard. Aning factors ng 2 that will give you a sum of negative 3. They're precisely negative 2 and negative 1, no? The factorization is x minus 1 times x minus 2. Tapos this is distinct linear. The partial fractions are a over x minus 1 plus b over x minus 2. And then let's do the process we did earlier of comparing coefficients. So clearing denominators, again, you'll be left on the left-hand side with this numerator here. That's now equal to what happens when you multiply this by this x minus 1 times x minus 2. For the first term, magka-cancel out yung mga x minus 1. You're left with a times x minus 2. Tapos for the second term, yung matitira sa inyo is b times x minus 1. And then let's distribute combined like terms. So for this one, get ax minus 2a. Ito magiging bx minus b. And then combining those x terms, you have a plus b times x. And then the constant terms are negative 2a minus b. Okay, let's try to compare coefficients. So what if, say, we compare the coefficients of x to the fourth? So on the left, we have the coefficient of x to the fourth to be equal to 2. Pero what's the coefficient of x to the fourth on the right? In this case, wala kayong makikitang term na x to the fourth, no? So the coefficient on the right is 0. And this is in fact a contradiction kasi take note, these expressions are supposedly equal for any possible value of x. So dapat magtugma precisely ang mga coefficients. Got here 2 equals 0, which is of course absurd. So, hindi tayo pwedeng mag-partial fractions agad-agad dito. Instead, let's divide the numerator here by the denominator. So, let's recall how to perform long division. We have here the division bar. Inside the division bar is your numerator, itong part na to. Tapos to the left of the division bar is your denominator, si x squared minus 3x. And then what you do is, you take the leading term of your numerator, which is 2x to the fourth, to divide that by the leading term of the denominator, which is x squared. Get 2x to the fourth divided by x squared. What is that? It is 2x squared, no? Then you align 2x squared here. Ka-align niya si 3x squared dito. Then afterwards, etong 2x squared na to, you take that and multiply that to the entire denominator. Particular, si 2x squared times x squared is 2 to the fourth. X squared times negative 3x is negative 6x cubed. And 2x squared times 2 is 4x squared. Then the next step is to subtract this entire thing to this product that we got. This one minus, what's 2x to the fourth minus 2x to the fourth? It's 0, no? X negative 7x minus negative 6. So minus minus, that's plus ngayon, no? Negative 7x cubed plus 6x is now negative x cubed. Tapos 3x squared minus 4x squared is negative x squared. And then we bring down these two, no? Kasi walang x and constant terms dito part na to. And then take note, ang goal natin is to obtain a polynomial of degree strictly less than this one. Tama? But if you notice, the difference that we got, its degree is still higher than the degree of our denominator. So in that case, you have to repeat the same process, this time involving this one. Take the leading coefficient, or rather the leading term of this one, which is negative x cubed, divide that again by the leading term of x squared. Negative x cubed divided by x squared, that's now negative x. Align negative x here. And then you take only negative x, multiply that to this one. Negative x times x squared is negative x cubed. Negative x times negative 3x is positive x squared. Finally, negative x times 2 is negative 2x. And then as usual, let's subtract that to this one. Negative x cubed minus negative x cubed, what will that give you? That gives you 0, of course. Negative x squared minus 3x squared is negative 4x squared. Negative 2x minus negative 2x is 0. And then you bring down 1 here. Tapos we still have here a polynomial with degree equal to the degree here of the denominator, no? So we still continue. Negative 4x squared divided by x squared is now negative 4. 4, again, you take only 4. Multiplied to this entire thing, you get negative 4x squared dito. Then negative 4 times negative 3x is positive 12x. And then negative 4 times 2 is negative 8. And then you subtract negative 4x squared plus 1 to this entire product. Get negative 4x squared minus negative 4x squared, that's a 0 ngayon, no? Tapos 0 to kasi walang presence ng x dito. So 0 minus 12x is negative 12x, of course. And then 1 minus negative 8 is now 1 plus 8, which is 9. If you notice here, what's the degree of this one that we got? It's now degree 1, no? It's now less than this degree 2 polynomial. So we stop here. At this point, we now identify what our quotient is and what our remainder. In this case, ito yung quotient natin, yung pinakataas. And yung remainder natin is yung pinakababa. So we can now re-express our original function here, this quotient. Is now equal to the quotient plus remainder, negative 12x plus 9, all over this denominator. Always remember, no? Quotient plus remainder all over divided. And then this one, this is what we resolve into partial fractions. Doing so, decompose this into partial fractions, the factorization of the denominator, x minus 1 times x minus 2, no? And then you get now for your partial fractions, a over x minus 1 plus b over x minus 2. And I will leave you to verify that the values of a and b that you will get are respectively 3 and negative 50. I want you to verify this on your. Okay, so we can now integrate this one. This integral is equal to integral ng quotient plus remainder over denominator. Pero this one, when we resolved into partial fractions, and then let's integrate this term by term. Starting with this, what's the antiderivative of 2x squared? So si 2 lalabas, what's the antiderivative of x squared? Again, you take the old exponent, which is 2, add 1 to that, you get 3, all divided by that same new exponent 3. So the total antiderivative is 2x cubed divided by 3. Dito, similar things will happen, no? You should get negative x squared all over 2. Negative 4, its antiderivative is negative 4x. And then for this is similar to an example we discussed earlier. You get 3 sa labas, and then antiderivative ng 1 over x minus 1 is now the ln of absolute value of x minus 1. And then similarly here, you should get minus 15 times the ln of absolute value of x minus 2, and then plus an arbitrary constant. And then that's it. Okay, that's it for our discussion for today. I will conclude with this set of exercises, and if you want more exercises, you can answer them. That's it. Thank you all for watching.